Okay, so today we are looking at basically using trigonometry for three-dimensional objects, or basically three-dimensional trigonometry. Okay, we're going to use a variety of trigonometry ratios and rules to solve problems involving 3D shapes or 3D geographical problems. We'll be successful if we can correctly sketch an image to represent the problem and correctly solve problems involving 3D shapes using trigonometry. So let's do some examples. Okay, here's an example from our Maths in Focus book. It says we have two straight paths to the top of a cliff, and they are inclined at angles of 25 degrees and 22 degrees to the horizontal. So here we got path 1 and path 2. It's 25 and 22. If path 1 is 150 meters long, we want to find the height of the cliff, and the height will be here. Yeah, so basically what we have then is we have a triangle that looks like this, where this is path 1, and that's 150 meters. We have 25 degrees there, and we want to find the height of the cliff. So in that sense, then we obviously have sine. Sine theta is O over H. Theta in this case is 25 degrees. Our opposite is H, and our hypotenuse is 150. So the height is 150 sine 25. Make sure your calculator is in degrees mode. And we press 150 sine 25. We get 63.39. Let's do it to the nearest meter. So let's say it's 63 meters. What I'm going to do, because I'm probably going to need this measurement later on, I'm actually going to store that into my calculator. And to do that, I'm going to press Shift RCL, which means so store, and I'm going to store it in either A, B, C, D, E, F. I'm going to store it in A. Okay, and basically what it does is it stores that number in A. And the reason why I want to do that is because I want to minimize rounding errors. Okay, so this is to the nearest meter, and I've stored this just to keep a note for myself. I've stored this in A. Okay. All right. The second part says find the length of path 2. So I know what my H is. I just found it. I know that this is 22 degrees angle of inclination. I want to find what path 2. So what I've got is I've got another triangle here. There's H. This is 22. And I want to find, let's call it X. Okay. So this will be another sine. So sine theta equals O over the opposite over the hypotenuse. In this case, it's going to be 22 degrees. My opposite is actually my H. So I'm just going to write H. And I want to find what X is. Okay. So using algebra, I now have X is H over sine 22. And what I'm going to do now, so that I don't put 63.39, I could use it now, but what I'm going to do, I can go straight from here, I can go divide by sine 22. Okay, so it's 169. Let's do it to the nearest meter. I'll store that in B. All right, so press Shift, recall, and I'm going to press the degree button, so it's going to be stored into B. The second part says, or part C, so this is part A, this is part B, Part C says, if the paths meet at 47 degrees at the base of the cliff, find the distance apart from each other. So what we have is we have a non-right angle triangle. That's 150, and I want to find what that is. Okay. And so what we actually have is we have the cosine. We have to use the cosine rule because we've got two known lengths and the inclusive angle. So the cosine rule is c squared equals a squared plus b squared minus 2ab cos c. Okay. C squared in this case will be y squared. A squared, let's say that's 150. My b squared is going to be my x. 2 lots of 150 times my x times cos 47. So what I could do is I can go 150 squared plus answer squared minus 2 lots of 150 lots of answer cos 47. So y squared equals 16,513, and I'm going to then square root that. So it's 128.5 meters, 1 dp. Okay. Now, obviously, if I've stuffed up or pressed something on my calculator by accident, I can calculate these things again because I can actually go. So h is in A, so I could go alpha A over sine 22, and I get my same measurement. Over here I could go, now I stored that number in B, so 150 squared plus alpha B squared minus 2 lots of 150 lots of B cos 47. Get that number, square root it, and I get my same answer. Yeah. So it is good to be able to store things into your calculator to recall it for later on. Okay. So that's the first example, using two right angle triangles, here and here, and then using the cosine to find this triangle here. Okay. All right. Here we have a rectangular prism, and basically we've got a triangle kind of in each corner. We've got a triangle in a corner. So it's kind of, imagine it's kind of sitting on a slant if it's inside the rectangular prism. We want to find the area of triangle ABC, and then we also want to find the angle of BAC. We want to find that angle there of that red triangle. All right. So I'm just going to label my triangle for the time being. So if this is angle A, then this is going to be small a. This side's going to be small b. And this side's going to be small c. Okay. So let's calculate BC. Yep, which is little a. And what I'm going to do is I'm actually going to use, so this is the base of the triangle. So on the base, we know that the base of the rectangular prism. We know rectangular prisms are pretty much all 90 degrees in each corner. So I'm actually going to use Pythagoras here. So using Pythagoras' theorem. Yeah, so this is the base of the rectangular prism. It's the diagonal of the base. So I've just got 5 squared plus 2 squared. So that's basically 25 plus 4 is 29. So BC is going to be the square root of 29. Okay. Let's now calculate AC. Still using Pythagoras, so just using Yep. So now we have, so this is the side of the prism, and we're using this part. So we've got 3 squared plus 5 squared. So 9 plus 25 is 34. Yep. And now we're going to calculate AB. Yep. So still using Pythagoras, we've got 2 squared plus 3 squared. So 4 plus 9 is 13. So 3 squared 9 plus 4 is 13. Yep. Okay. So if we want to calculate the area of a triangle, so this is using non-right angle triangles, the formula was A equals a half AB sine C. Okay. And let's just use these letters, right? So a half, our A is square root 29. Our B was square root 34. And now we want sine C. We want this angle here. Now we can't calculate that angle just yet, but what we don't actually know what that angle is just yet, but we could use the cosine rule. So the cosine rule, so I'll just put a line here, we'll get back to this part. So the cosine rule says cos of C equals A squared plus B squared minus C squared over 2AB. Okay, so C is inverse cos of the side that's next to it, so A is going to be square root 29 squared plus B squared, and B is 34, minus C squared, which is 13. All over 2 lots of A and B, so 29 and 34. Okay, so now I'm just going to plug that into my calculator. So degrees cos is 29 plus 34 minus 13, because a square root to the power of 2 just cancels each other out and just comes 29. Yeah. All over 2 lots of square root 29, lots of square root 34. Yeah. So 37 degrees, 14 minutes and 55. I'm going to store that in A. Okay, which means that that angle is now this. So I can now calculate the area. So a half of square root 29 times square root 34 sine A, or 37 degrees and 40, right? So the area is 9.5. So we're in units, squared units. Okay. So that is the area of A, B, and C. All right. We want to find the angle of BAC. So that's this angle here. Okay. Because I've used the cosine rule to figure out this, I can use the cosine rule to do that. However, just for differences, or just to have a different example, I'm going to use the sine rule for this one now. Okay, so the sine rule says sine A over A is the same as sine B over B, which is the same as sine C over C. Okay, so if we want to find what sine A is, and that's opposite square root 29. We know what's that sine C is, so sine C was 37 degrees, 14 minutes and 5.4 seconds, over C, and that was square root 13. Okay, cross multiply, I get square root 13 sine A is square root 29 over sine 37 degrees, 14 minutes and 5.4 seconds. Divide by square root 13. And then we want to have the inverse. So inverse sine is square root 29 of sine A over square root 13, and I get 64 degrees, 39 minutes and 13. Okay, and if I run it around it to the nearest degree, 39 is bigger than 30, so it's going to be 35 degrees. Okay. All right. Here's another example. This is from our Cambridge textbook. We have two monuments, A and B. They're 400 meters apart on a horizontal plane. So this is going to be 400 meters. The angle of depression is 18 of A from the top of T of a tall building is 18 degrees. And angle TAB is 52 degrees, and angle TBA is 38 degrees. We want to show that TA is 400 cos 52. That's what we've been given something that we want to show. Okay, so we want to figure out what this height is here. Okay, so looking just at triangle TAB, yep, I know that that is 52 degrees and this is 38 degrees. So I'm just going to put into my calculator to just figure out what angle ATB is going to be. So 180 minus 52 minus 38 gives me 90. So what I found out is, even though the picture doesn't look like it, what we actually have let's do it bigger. Okay, so I've actually got this triangle here. Okay, so it says that I want to show that angle show that TA is worth 400 cos 52. So the first thing I need to do, this is for A, so the first thing I need to do for A is show that angle ATB is 180 minus angle tab and minus TBA. BA because they're angle sum of a triangle. So angle ATB was 90. Therefore, triangle ATB is a right angle triangle. Okay, so therefore, cos theta is adjacent over hypotenuse. So cos 52 is adjacent, which is my TA over my hypotenuse is 400. Multiply both sides by 400, so TA equals 400 cos 52. So I have shown through all these steps and through my communication that TA equals 400 cos 52. And you can put, yeah. So you could say, so required to show TA equals 400 cos 52, and then here as required. Okay. Part B says we want to find the height of the building. Okay, we want to find that height there. So we have what we have is that we now know what this measurement is. We now know what TA is. Yeah, I can write it down as 400 cos 52. So 400 cos 52. Okay. But if I look at this three-dimensional diagram, if this angle of depression is 18, then this part here is also 18. So what I now have is a right angled triangle on this side where that's going to be the H. This is TA. We know that this is 400 cos 52. And we know that this is 18 degrees. Okay, so part B, we want to find the height of the building. Well, that's just sine. So sine of theta is opposite over hypotenuse. We know that theta is 18 degrees. Our opposite is the height of the tower, and the hypotenuse is 400 cos 52. Multiply both sides by 400 cos 52, we get the height is 400 cos 52 times sine 18. We can plug that into the calculator. So 400 cos 52 times sine 18, we get 76. Let's do it to the nearest minute. 76 meters. Nearest meter. I might need to use this number again, so I'm just going to store that in A. Okay. All right. So now we want to find the angle of depression of B from T. We want to find out what if we had another parallel line. Yeah, we want to find this angle depression, which is the same as this angle here. So we now have this other triangle on this side. Yep, we've got T, C, B. We're trying to find this angle here. Let's call that theta. We know that H is that, 400 cos 52 sine 18. We want to find that angle there. And so what we need to have is one more measurement. So I feel that because this is a right angle triangle, we'll find out this one here. Let's call it y. Yeah, that's probably the easiest part. Okay, so y squared is going to be, basically using Pythagoras, is 400 squared minus 400 cos 52 all squared. So therefore y is going to be the square root of that. Okay, so knowing that, we can now use sine to get that degree. Yep. So sine of theta is O over H. We want to find, so sine theta has to equal the opposite, which is 400 cos 52 times sine 18, all over what y is, which is the square root of 400 squared minus 400 cos 52 all squared. So plugging that into our calculator, we got 400 cos 52 times sine 18 over the square root of 400 squared minus 400 cos 52 all squared. So we get an angle of elevation of 13 degrees, 58 minutes, and 15.55 seconds. Okay. All right. This is our last example. The trick here, the reason why I've put this one here is so that you may get a question or worded question where you are asked to draw the diagram, or you're not even asked to draw the diagram, but that's the first thing you should do. Okay, the first thing you should always do is have a diagram. The diagram needs to be big enough so you can write things into it. At least a quarter of a page, or as big as possible, so that you can write things into it. Or I would always do it in pencil. Okay, so let's read this. From a point P, due south of a vertical tower. So it means I'm going to have a tower. Oh, why not? This is my tower. Okay. I've got a point which is due south. Due south is kind of there if we had north going up. But you don't need north to be up. So what I like to do is have north going at an angle. So if that's north, this is my point P. Yeah, it is due south, yeah, of my tower. So if that's the case, then I'm just going to create some more. Yeah, because that's going to be east out here, and that's going to be west. Okay, so there's my tower. The angle of elevation of the top of the tower is 20 degrees. So from here, I have this angle here, which is 20 degrees. So from a point P due south of a vertical tower, the angle of elevation of the top of the tower is 20 degrees. From a point P situated 40 meters from P, so point Q situated 40 meters from P and due east of the tower. So I have this point over here, which is now Q. It is 40 meters from P. And due east of the tower, the angle of elevation is 35 degrees. Okay. Let H be the height of the tower. Okay, and now we want to calculate the height of the tower. Okay, so what we have this as a right angle triangle over here, this way. We have another one going this way, and we have a right angle on the floor. Yeah, and so we want to find the height of the tower. Okay. Looking at, let's just call these points A, B. Yep, okay. So looking at triangle ABQ, angle BAQ will have to equal 180 take away 90 take away 35. So this angle up here is going to be 55 degrees. And then looking at triangle ABP, the angle BAP will have to equal 70, because 180 minus 90 minus 20 is 70. Okay, so we could kind of think of this way. That's the height of the tower. We've got two triangles out this way. That's B, P, so 20, that's 70. This is Q, this is 35, and that's 55. Okay. We don't know those two measurements there. Okay, but we want to find out what the height of that tower is. So, okay, so we obviously know these angles. We don't know these measurements, BP and BQ. So looking at triangle ABP, we can figure out that tan 70 is the same as the opposite over the adjacent, which the adjacent is H. So it's BP over H. And we can rewrite it as H equals tan 70 over BP. Similarly, looking at triangle ABQ, tan of 55 is going to be the same as opposite, which is BQ over H. And I can rewrite that as H tan 55 equals BQ. And the reason why I wanted to do that is because I know that Q was due east and P is due south, so that creates a 90-degree angle on the flat surface. So now BQP is a right angled triangle, and I can use Pythagoras' theorem. Okay, so PQ is squared is the sum of BQ squared plus BP squared. Okay, so we know that PQ was 40. Yeah, so 40 squared equals BP, and BP we've written it as H tan 70. So H tan 70 all squared plus BQ, and that's the same as H tan 55 all squared. Okay, so expanding that out, I get 40 squared equals H squared plus tan 70 all squared, and the way I write that is I put the square sign in between tan and 70, plus H squared plus tan 55 all squared. Put the 2 in the middle. I'm going to factorize, so take out the H squared. So H squared is tan squared 70 plus tan squared 55. Divide by both sides by this part. You get H squared equals 40 squared over tan squared 70 plus tan squared 55. And now I just plug that into the calculator. Okay, so I got, so I want to do the square root of the top and the bottom. So remember with surds, the square root of all of it is the square root of the top as well as the square root of the bottom. So square root of 40 squared is just 40. And the square root of tan 70 all squared, note how I've written it into the calculator, plus tan 55 all squared is 12.91785. Yeah, and to one decimal point is 12.9 meters. Okay, so thank you. All right, the more you practice with these and the more you do them, the better you actually do become at this. Okay, thank you very much. Bye.